All right then, let's get into it. Imagine this, right? It's the golden age of shortwave radio. Signals are flying all over the place, connecting the entire globe. But what if the secret to a rock-solid signal wasn't just about your rig, but had everything to do with where the planets were in the sky? Sounds a bit mad, doesn't it? Let's have a look.
I mean, seriously, could Jupiter actually ruin your chances of a great DX contact? It sounds absolutely bonkers, doesn't it? The idea that some massive gas giant millions of miles away could affect you trying to reach that rare station in the middle of nowhere. But believe it or not, for one of the biggest companies on the planet, this wasn't just some daft theory. It was their actual business plan.
So let's set the scene. It's 1946. The war's over, and shortwave radio is the way the world talks to itself. But there was a massive problem. These completely unpredictable magnetic storms would just pop up and kill the signals stone dead. For a massive company like RCA, that's the Radio Corporation of America, this was a total nightmare. Imagine you're running this huge global network and boom, without any warning, everything just goes silent. They absolutely had to find a way to predict this static.
So let's get into it. Section 1, a cosmic radio problem. And that's exactly what it was. This wasn't some local interference, this was coming from space. So you'd have to look to space for the answer, wouldn't you? And this is where our main character comes in. Meet John H. Nelson. He was an RCA radio engineer, a keen amateur astronomer, a proper boffin, you might say. And RCA gave him a pretty impossible job: predict the static. They even plonked an observatory on top of a building at Manhattan for him. His mission? Figure out how to forecast these blasted magnetic storms. And the idea he came up with? Well, it was out there, literally.
Right, on to his big idea then. Nelson's planetary forecast. Now, most people at the time were just looking at the sun for clues, sunspots and all that. But Nelson? Nah. He decided to look at the whole shebang, the entire solar system. And what I love is what Nelson himself said about it. Have a look at this quote. He's basically saying, look, I don't have a solid theory for this. He wasn't some physicist with a grand unified theory. He was an engineer. He was looking for a pattern, something that just worked. And his big idea was to see the sun and planets as this massive electrical generator, with the planets zipping around and somehow tweaking the sun's output. Now, this is the really clever bit. This wasn't astrology. Absolutely not. Astrology is all about how things look from Earth, right? Nelson's system was completely different. It was heliocentric. That means it was all about the geometric angles between the planets, as if you were standing on the sun, looking out. It was purely mechanical, like clockwork. And here's the rulebook he came up with. It's actually dead simple. He figured out that when planets line up at certain angles, 0, 90, 180 degrees, which he called hard angles, you'd get bad radio conditions. But when they were at these other soft angles, like 60 or 120 degrees apart, everything was great. Stable, clear signals. It was his system for forecasting the cosmic weather, and it was beautifully simple. Okay, so this is where it gets really good. RCA's secret weapon. Because you see, RCA didn't just think, oh, that's a quirky idea. No way. They actually used it. For them, this was a serious tool for the business. Just let that sink in for a moment. For over 25 years, a quarter of a century, one of the biggest tech companies in the world was planning its global shortwave traffic based on where the planets were. If Nielsen said a storm was coming because of some planetary alignment, they would literally reroute their signals to avoid it. It became their secret weapon.
So why on earth did they trust him so much? Well, it's because of this number: 90%. Nelson claimed his short-term forecasts were 90% accurate. Now, if you're an engineer, a number like that, you just can't ignore it. It really looked like his system just plain worked.
But you can probably guess what's coming next, can't you? The scientific static. Yeah, the rest of the scientific world started to raise an eyebrow or two. They started to, tune in and see what all the fuss was about. So, to properly test Nelson's idea, scientists needed something to compare it against, a control, and they used a much, much simpler idea. We know the sun spins on its axis about every 27 days. So if a sunspot is causing trouble, it's likely to cause trouble again 27 days later when it swings back around. So the big question was, could this dead simple 27-day cycle predict things just as well as Nelson's complex planetary charts? Or maybe even better?
And here we go, the moment of truth. Researchers went back and crunched 18 years of Nelson's forecasts, and the result? The correlation between his predictions and what actually happened was, well, basically zero. Nothing. No statistical link at all. Meanwhile, that simple 27-day forecast? It showed a small but definitely real connection. Ouch. That had to hurt.
So what about that amazing 90% accuracy figure? Well, this is where it gets a bit tricky. Someone pointed out a classic statistical trap. You see, it turns out that shortwave radio conditions are actually pretty good about 90% of the time anyway. So if you just predict good conditions every single day, you're going to be right 90% of the time. It sounds impressive, but it doesn't mean you're actually predicting anything at all. And this was pretty much the final nail in the coffin. Nelson had this one event, a massive radio blackout in 1940 that he called his Rosetta Stone, the absolute proof his theory worked. But when other researchers looked closer, they found a planetary alignment that by Nelson's own rules should have been way worse just 10 days earlier. And what were the radio conditions on that day? They checked RCA's own logs, and they were perfect. The whole theory just fell apart.
So, that's that then. Case closed. The theory was a bust. Well, yes and no. Because if we just leave it there, I think we're missing the most interesting part of the whole story.
Okay, so the theory didn't quite cut the mustard when the scientists got their hands on it. But come on, what an absolutely brilliant story. It's that maverick spirit of curiosity, isn't it? That what-if thinking that every single one of us radio amateurs knows. You know, when you're messing about with a new bit of wire for an antenna or trying some new digital mode, it's the fun of just trying something new.
And you know what? The story isn't quite over. There's a kind of modern cosmic echo. While Nelson's exact theory was debunked, this big idea that the planets could influence the sun hasn't completely gone away. Scientists today are looking into something called solar inertial motion. It's basically the idea that the massive pull of planets, like Jupiter, makes our sun, well, wobble. And could that wobble affect things like sunspots? The jury's still out, but it proves Nelson was asking a really interesting question. And really, that's what we should take away from all this. Nelson's planetary forecast is just a cracking piece of radio history. It's a great reminder that sometimes the most exciting ideas are the ones that are a bit out there, the ones that push the boundaries, even if they turn out to be wrong in the end. It really makes you wonder, doesn't it? What's the next wild theory in radio going to be? What's the next big, brilliant, and maybe slightly bonkers idea that'll change our hobby? Something to think about. 73 for now.